All right, so the first problem asks us to name a radius, which we know is any line segment that starts at the center point and goes to the edge. So maybe like A to C would be a good option. Whoops. AC, you could have also done AB, AD, anything like that. Diameter is a little bit different. It's from edge to edge of the circle, so the full way across, and you have to pass through the center point. So maybe we could call this BD, or DB would work. Okay, and then of course for the rest of our study guide here, we're going to need to use the same two formulas. Circumference is equal to pi times the diameter of the circle, and then area is equal to pi times the square of the radius, like radius squared. So of course, those are your two formulas that we've been using, so you can look back to those for reference for the rest of your study guide. Okay, find the circumference of the circle. So our formula for circumference is equal to pi times the diameter. So we need to go to our formula, or I'm sorry, to our circle here and get the diameter since they only give us radius. Well, if we know that edge to the center is 33, well, this edge to the center must also be 33. And if we do that, we're able to find that our diameter, or all the way across, has to be worth 66 centimeters. Okay, so we go back to our formula. C equals, we can substitute in 3.14 for pi, times our diameter, which we said was 66. Now we have our multiplication problem. We can go right to our calculator, and we're going to plug this in and see what we get for circumference in centimeters. So 3.14 times 66 gives us 207.24. 207.24 centimeters for our circumference. And of course, that's, again, the distance around the circle. Okay, so moving on to page 2, we want to find the area of the circle. So our formula for area is equal to pi times radius squared. So we need to make sure we have what we need in this problem. They give us diameter, we need radius. So if diameter is the full way across, right, which is 20 feet, radius is just halfway from the edge to the center. So that would just have to be 10 feet. And now we have everything that we need. So area is equal to, again, we're going to substitute in 3.14 for pi. And then we're going to, for radius, we're going to put 10, and you need to make sure you square it. And I'm even going to take another step of rewriting this problem before even doing the evaluating the pi. I'm just going to rewrite 3.14 times 10 squared, I know has to be 100. So I always like to just do that. That way you don't forget that step. Actually evaluating the squared. And then all we have to do to get our area, type in 3.14 times 100. Let's draw our arrow here down to our answer box. That's going to give us an area of 314 square feet. Okay, Jackson rides a Ferris wheel that is 85 feet tall. So the first part that they want us to do here is to draw and label a radius on the diagram. So of course, radius is from the center point to the edge. So maybe it looks something like that. And we have to be careful. We can't just put 85 for that, because if you think about it, they're telling you that the entire Ferris wheel, the entire thing is 85 feet. So from top to bottom, like this. So how could we find radius? Well, radius has to be half of that. So 85 divided by 2, 42.5 feet would be our radius. And then, of course, they didn't ask us to do this, but we might as well just label it. I'll put in blue just to make it a little bit more clear. 85 is our diameter. And we're going to need to use those two numbers in the rest of the problems. So they want us to know, or to figure out, how many feet will Jackson travel going around the Ferris wheel once? Well, if you think about the path he would take going around the Ferris wheel, that's really circumference, which we know is equal to pi times the diameter. Well, we know pi is always 3.14, and in this case, diameter, which is the height from the bottom to the top, we said was 85. So we can put that right into our equation. Again, here's a multiplication problem. All we have to do is type it in our calculator. So pi, or 3.14, times 85 gives us 266.9 feet. And again, that is not feet squared because circumference is just a distance. It's a length. So it's just regular feet. Okay, follow-up question. How many feet would Jackson travel if he went around the Ferris wheel 6 times? Well, we already figured out that one trip around is 266.9 feet. So it's the same. The circle is not changing, so we just have to multiply that by 6. And let's see. So 6 trips around the Ferris wheel would give him a distance of 1601. So 1,601.4 feet. So 1601.4. And again, we didn't even have to go to the circumference formula again since we already had the circumference. You just have to multiply that by 6. Okay, moving on to our third page. So the chair swing ride at Hershey Park has a radius of 46 feet when in motion. So think about this ride at the amusement park, right? When it starts to go, the chairs that you're sitting in start to form a circle when you move. And we want to think about, well, the circle that is made by those, what would be the area in square feet? So they tell us, and again, this is going to be a little hard to draw, but picture the circle that's formed by these going in their motion, right? They're telling us the radius, or from the center of the ride out to the edge, like the farthest that the swings could hang out, is 46 feet, which is what we're going to need for our area formula. We know area is equal to pi times radius squared. So we can go make our substitutions. Pi is just equal to 3.14. In this case, our radius is 46, and don't forget to square it. Just like the previous example that we did, I'm going to rewrite this. Not going to change anything with the 3.14, but I am going to figure out what 46 squared is. So 46 times 46 is 2,116. This gives us our multiplication problem. We go right to our calculator and see that we can get 6,000. So 6,644.24 square feet, which would be the area that is created by the circle when those swings are in motion. Okay. We know the radius of a car wheel is 9 inches. We want to find the circumference of this should say wheel, I'm sorry, in terms of pi. So if it's asking us for circumference, we know our formula must be C equals pi times diameter. If we think about the information that they gave us, they told us radius of 9 inches. Well, that means radius is halfway across the circle. Diameter is the full way across. So we need to multiply this by 2. So diameter is equal to 18. Okay, if we go back to our circumference formula, C equals. Now, all of the examples so far, we've been replacing pi with 3.14, which we know pi is an irrational number, meaning it never stops. It's a decimal that never ends. So when we write 3.14, we're really estimating. This wants us to get the exact answer, which means do not put in 3.14. Just leave the pi symbol in there, times our diameter, which is 18. And again, they want exact. So our answer for this, which means do not evaluate pi, is just circumference is equal to 18 pi, which would be answer C. Of course, we could put that back into our calculator and push the pi button or 3.14 and get an estimate, but this would be your exact answer, 18 pi. All right, we're so close, we're on the back page. So the diagram to the right is a scale drawing of a metal flywheel and a car engine. And we want to think about how much metal will we need to make the flywheel. So you have to decide, are we finding area or circumference? Well, if it's asking how much metal, I'm thinking that means area, right? The amount of metal that we would need to actually create this flywheel. So we're looking for area, and always start with your formula, which is pi times radius squared. So if we go on to our diagram here and look for radius, we know that 1, 2, 3, 4 blocks, right, makes up our radius here. However, they give us this scale. They tell us each block is worth 13 centimeters. So we need to multiply that 4 by 13. Think about it, it's just a scale drawing. If we go to our calculator, 4 times 13 gives us 52, which will be the radius that we're going to need to use. And this was centimeters. So 52 centimeters. I'll add that in. Okay, so we have everything that we need. Area is equal to, we'll substitute 3.14 in because it doesn't say exact. We can round, times radius, which was 52 squared. Just like we've been doing with the area problems, I'm going to first evaluate that 52 squared, which is 52 times 52, which gives us 2,704 for that. We've got ourselves a multiplication problem. Go right to your calculator. We're going to put this in. And we know that if we wanted to find area here, we would get 8,490.56 square centimeters. So that's the amount of metal that we would need if we wanted to make the flywheel, just based on the area here. So the big takeaway with this problem was remembering to use that scale that they give you, right? I always just like to use that right at the beginning so that I can go to my formula and just do it just like normal. Okay, our last problem here on our study guide is to find the perimeter of this figure. So we have to think, anytime you see what we call here a composite figure, meaning it's a weird shape that is made up of shapes that you know or can recognize. So I see that in the middle, we have this equilateral triangle, which we know a lot about. And then if you look closely, the two outside shapes, these are really just half of a circle, which is called a semicircle. And we're going to be able to use the two formulas that we've been studying so far to figure out we need perimeter. So we'll be able to use them to find the circumference of these circles. Okay, so just add some color here so you can see the two pieces. The triangle part is really nice. Again, we want perimeter, so all of the distance on the outside. We don't have to do anything with the triangle because they tell us that that is 28 feet. However, for the circle parts, we know we need to find the circumference here to figure out the perimeter. So if we put that in, we know the diameter has to be 28 because of this side. And using our circumference formula, that gives us 87.92. But each of these circles, it's really only half of the circumference. So each one is 43.96. So we can add that in. And then last step is to just add that up. So we're going to see what we get there. Okay, so if we add up our 28, our 43.96, and 43.96, we should get a total perimeter of 115.92 for this problem.